So guys, this is another short video difference between colorimeter and spectrophotometer. Okay, first of all we discuss about what is the role of colorimeter and spectrophotometer. Basically it detects the solute inside any solution. Okay, so suppose this is a serum sample and inside we have a urea particle. Okay, but we have to measure the amount, okay, how much they are present, and this is called solute. So we have to check the solute inside our any solution by using colorimeter and spectrophotometer. Now for the colorimeter, as the name suggests, color. So by the colorimeter we can only detect solute inside a color solution, while spectrophotometer we can detect solute whether the solution is color or colorless solution. It may be transparent. Okay, first of all we discovered some basic principle, okay, for both of that. So when a light come from a source, strike to the particles that present inside any solution. Okay, so suppose we are giving 100% light, but on the other side we see only 30% light. Okay, if we calculate the net absorbance, so what we see, 100 minus 30, okay, it will give 70. So ultimately we can say that the absorbance is around 70%. Okay, so this is the basic principle. So now in the colorimeter we use only visible range wavelength. It mean you all see a term Vibgyor, okay, that denotes the color of a rainbow. So inside the electromagnetic spectrum we have so many types of rays. Okay, this colorimeter only based on a visible range. Okay, starting from 400 nanometer to 700 nanometer. Okay, red one is 700 and our violet is a 400 nanometer. Very important. So this colorimeter based only on this range, while in spectrophotometer we can also detect solute in a colorless solution. So for that we have to go up and down from this visible range. That's why in the spectrophotometer we are using ultraviolet or infrared wavelength. That's why here in the spectrometer we are using wavelength in or out of the visible range. It may be more than 700 and less than 400 we can also use in case of spectrophotometer. Now another thing is that in the colorimeter we are using a filter to giving a particular wavelength. Now what is the meaning of that? So in a colorimeter we have a this filter type, okay, a filter which is circular in shape, and suppose this is red in color and this one is blue in color, this one is green in color, and this one is yellow in color. Okay, now every solution having their own color definitely for the colorimeter. Okay, suppose we have a green color of our solution due to adding of reagent for a specific. In case of urea we add damp solution of, suppose it create a green color. So it is already noticed or described by scientists that green color absorb maximum light at red filter. Okay, so in this case we are using this red filter. Suppose from the source we are getting a multiple rays. Okay, it mean blue, green, red, all, but we have to pass only red light because green solution absorb maximum red light and it is very sensitive to determine our solute. So that's why we use filter to filter the particular rays. Okay, and this is red for green solution. I hope you understand. But in case of spectrophotometer we are using a prism or diffraction grating. Okay, so you can see this is like a prism. Okay, if you pass a light, simple light, this is a white light. Okay, this will create a Vibgyor. After that there is a slit which will pass selective light. Suppose we have a red solution, so it will select pass only green light from here slit. Okay, all the light are strike to there and they stop from passing toward the solution. I think you understand. Now in the instrument we have to use a cuvette. Okay, cuvette nothing but a type of glass vial, or we can say plastic vial according to the our equipment in which we hold our sample. Okay, inside the machine. In case of colorimeter you can take example of this vial. Okay, like that we have a cuvette. For colorimeter the cuvette may be a simple glass type or it can be a plastic cuvette, but in case of spectrophotometer a special type of glass called quartz or silica glass cuvette we are using in spectrophotometer. Okay, now this colorimeter is cheaper and less accurate. So why this is less accurate? Because all the principle to get the solute exact concentration based on formation of color, and the formation of color may be disturbed by not giving a proper time. Okay, it can be due to by adding reagent to the solution, it needs some heating, and we not give a proper heating to the solution ever, and it does not develop a appropriate color. Okay, so that's why it is less accurate, because totally depend of color. While in case of spectrophotometer, we are also examining a solute inside a colorless solution. So that's why this spectrophotometer is more accurate than this colorimeter, and that's why the range is very costly as comparison to colorimeter. So this is just a brief introduction, or we can say differentiation between the colorimeter and spectrophotometer. Usually asked in the exam, it may be viva or it may be in theoretical. Thank you.